Namaste students. Today we are going to start with the last topic of indefinite integration, that is the integration of the rational function of the form x squared plus 1 upon x raised to power 4 plus kx squared plus 1, quadratic upon biquadratic, and the same way x squared minus 1 upon x raised to power 4 plus kx squared plus 1 where k is a constant. K is any constant, so k can be 0 also. Is it clear? That's not a problem. Now what do we have to do in such kind of questions? If we get this form, you have to divide the numerator and denominator by x square. We have to divide the numerator and denominator by x square. Alright. Then you have to put x plus 1 by x is equals to t or x minus 1 by x is equals to t. Why do we need to put? When I differentiate, what I'll get? 1 by x ka differentiation minus 1 by x square. Alright, I hope you remember this. That's the first topic. 1 by x. Differentiation I am doing, not integration. Power minus comes in front, reduce the power by 1, so minus 1 by x square. Is it clear? If I substitute this, then whatever after dividing by x square in the numerator will become the differentiation of this. अगर तो क्वेश्चन में माइनस है, when I divide this, what I'll get? 1 plus 1 by x square. When I divide the numerator by x square, what I get? 1 minus 1 by x square. देखो, ये बन गया 1 minus 1 by x square. इसका मतलब अगर ये बनता है 1 minus 1 by x square, तो हम सब्स्टिट्यूट करेंगे x plus 1 by x को. अगर बनता है 1 plus 1 by x square, तो सब्स्टिट्यूट करेंगे x minus 1 by x को, so that I get डिफरेंशिएशन इन द न्यूमरेटर. जो न्यूमरेटर में बनेगा वो इसकी डिफरेंशिएशन बन जाएगी. प्लस में माइनस वाला सब्स्टिट्यूट होगा, माइनस में प्लस वाला सब्स्टिट्यूट होगा. दिस यू नीड टू रिमेंबर चिल्ड्रन. इज दिस क्लियर? ऑलराइट, विल पिक अप क्वेश्चन, देन द थिंग्स वुड बी मोर क्लियर टू यू ऑल. सपोज लेट्स राइट अ क्वेश्चन. We have to integrate the first question. I have to integrate x squared plus 1 upon x raised to power 4 plus 1. Alright, here your k is 0. The term which has k is not there. That means k is 0. x square वाली term नहीं है तो कोई फर्क नहीं पड़ता. I told you k is a constant that can be 0 also. Rule remains same. I will be dividing the numerator and denominator by x square. So what do I get? X square by 1, this 1 by x square. X square plus 1 by x square gx. Alright. I told you when we have a plus, so I'll substitute the minus 1. X minus 1 by x is equals to t. Differentiate 1 x की differentiation 1. 1 by x की minus 1 by x square. Clear? So I have got 1 plus 1 by x square dx is dt. What about denominator? What about denominator? See how denominator will come here. Squaring both sides. Squaring both sides. What I'll get? A square plus b square minus 2ab. That means only 2 because x into 1 by x will be cancelled. T square. Always whatever is in the denominator, if you have to find out that value, that will be found by squaring both sides. That will be found by whatever you will get in the denominator. Always it will be of this form. Clear? So you will be squaring both sides and you will get the value. So I will get t square plus 2. So what did I get? I have to integrate 1 upon t square plus 2. Can you tell me which form it is? Can you tell me which form it is? This is integration of 1 upon x square plus a square. Integration of 1 upon x square plus a square. What was the integration? 1 by a tan inverse x by a. 1 by a tan inverse x by a. Substitute the value of t. What was t? That's my answer. Alright children, so keep in mind, if it is in this form, if you have a term of x square also, then also it's okay. You have to divide numerator and denominator by x square. If it has plus here, so substitute x minus 1 by x is equals to t. The moment you will differentiate, you will get the numerator there. Alright, and numerator and dx will be adjusted with dt, and denominator's value you will always get by squaring both sides. The moment you put that, you will get one of the forms which we have already done. Let's see the next one. I have to integrate 1 upon x raised to power 4 plus x square plus 1. Now if I see to the question, it is not in the form which we are doing it. For the form which we are doing it, in the numerator it should have either x square plus 1 or x square minus 1. That's important. Clear, but that's missing. So we will not be able to solve this question until unless it comes in a proper form that you know since beginning of integration. So I have to bring x square plus 1 or x square minus 1. So what am I doing? By constant we can multiply and divide, there is no problem. I'm writing this 2 as 1 plus 1. Alright, then I am adding x square into it and subtracting x square. There's no problem in that. Got it? So you have to introduce x square there. But you can't multiply and divide by x square. So first of all, constant I have brought 2. I have written 2 as 1 plus 1. Then I have added x square and subtracted x square because it has balanced the question. Now my I has become in two integrals. One is x square plus 1 upon this, and 1 I am taking minus out. So I have to solve it as two questions. It has become 1 by 2 I1 minus 1 by 2 I2. So separately I have to solve these I1 and I2 and then put the values in 1. Let's solve it. The first part. What is I1? X square plus 1 upon x raised to power 4 plus x square plus 1 dx. So what am I going to do? Divide it by x square. The step remains the same. If I divide by x square, it will become x square. If I divide by x square, it will become 1. So I am keeping it at the last. 1 divided by x square will be x square. Okay? Now what is the next step? If numerator has plus, I always substitute the minus 1. Okay? X minus 1 by x. So 1 plus 1 by x square. Dx is equals to dt. So I1 has become dt 1 upon. I need to find the value. Squaring both sides, you know it. So automatically will be x square plus 1 by x square minus 2 is equals to t square. So x square plus 1 by x square is t square by 2. T square plus 2. 1 is already there. So again the same form. 1 upon x square plus a square. What is the integration? 1 by a tan inverse x by a. C1. Replace the value of t, tan inverse x minus 1 by x by root 3. You want to take LCM, that also can be done. So we have solved I1. Let's solve I2. What is I2? Divide numerator and denominator by x square. X square 1 by x square. I am keeping it with it because I get the value together. And dx. Alright. Now what do? We substitute. So substitute If it is minus, I'll substitute plus 1. One minus x square, 1 upon x square, dx is equals to dy. So I2 has become 1 minus 1 by x square, dx is dy. And denominator, when I square both sides, x square plus 1 by x square plus 2 is equals to y square. So it will be y square minus 2 plus 1. Which form, children, it is? 1 upon y square minus 1. Which form? 1 upon y square minus 1. That means 1 upon x square minus a square. What form it was? 1 by 2a log of x minus a upon x plus a plus c2. Put the value of y back. That is so we have solved, we have integrated I1, we have integrated I2. Now we just have to substitute the value of I1 and I2 and then solve it. We want to little simplify both the things further, we can. If I take LCM, it will be x square minus 1 upon root 3x. Alright. And if I take LCM this side, x square minus x plus 1 upon x, x square plus x plus 1 upon x and x cancel. So what do I get? 1 by 2 I1, that is root 3 tan inverse x square minus 1 upon root 3x. And after taking LCM, if I simplify I2, I get 1 by 2 is already there. So 1 by 4 log of x square minus x plus 1, x square plus x plus 1 plus c1 and c2 will become some constant, let it be c. Is it clear? Fine. If you have 1 upon biquadratic, clear, x raised to power 4 plus x square plus 1, I have to have x square there to get into a proper form and to solve it. So we have multiplied by 2, divided by 2, added x square, subtracted x square, then it has come into a proper form which we know how to proceed with. Alright children, let's see the next question. Under the root tan theta. Under the root tan theta. See, there are some different questions. Alright, so once you practice, then only next time you'll come to know what to do in this such kind of question. So always put a star or put important or put different. So highlight such kind of questions. Alright, root tan theta, no form, nothing. I know the integration of tan, but I don't know the integration of root tan theta. So what am I doing? When nothing works, substitution works. When nothing works, substitution works. So substitution का substitute क्या rule है? एक तो जिसका differentiation दे रखा है उसको substitute करो. Fine, that we know. या फिर कई बार ऐसा होता है जो problem चीज नजर आ रही है ना उसको substitute करके देखो. You may come to some answer. I don't know the integration of root tan theta, so I am substituting complete root tan theta is equals to t. So what do I get? So tan theta is equals to t square. Now differentiate both sides with respect to t. I don't have secant square there, so I am bringing secant square this side. This secant square can be converted into tan square, so 1 plus tan square theta. I have a value of tan square theta, that is 1 upon tan theta is t square, so tan square would be t raised to power 4 dt. So I got all the values. I have d theta is equals to 2t upon 1 plus t raised to power 4. Let's substitute the values. Root tan theta is t. D theta is 2t upon 1 plus t raised to power 4. So, are we closer to some form? Have we done this form? This is t square 2t square upon 1 plus t raised to power 4. Now for the forms which we have done, it should be t square plus 1 or t square minus 1. I have t square, but t square 1 plus 1 and t square minus 1, that I have to make it. ठीक है, अब ये नहीं करना बच्चों कि लाइक यू डू इट टू आउटसाइड, इसमें +1 ऐड किया, -1 किया, एक पार्ट तो ये बन गया, यहाँ पे अटक गए। ऑलराइट, क्वेश्चन बैलेंस होना चाहिए, ये नहीं कि पहले t2 आउट, t² में एक 1 ऐड कर दिया, 1 सब्ट्रैक्ट कर दिया, जब स्प्लिट किया ये वाला पार्ट तो क्वेश्चन बन गया, बट 1/t⁴ + 1 तो फिर प्रॉब्लम हो गया। वो तो पीछे भी हमने किया था, ऐसा कुछ है तो t² इंट्रोड्यूस करना है। सो यू हैव टू थिंक वाइजली and then do it. Don't jump on the conclusions. That's very important. So I have 2t². अगर ये 2 नहीं होता तो हम बनाते। Reason, I'm going to split into 2 parts. 1 I'm adding 1, 1 I'm subtracting 1. Now the question will become balanced. Clear? Now this is the first form, t² + 1 upon this. And this is the next one. Alright, I will solve it separately as I1 plus I2. And we know that how to solve these questions. In this I1, I will divide it by t², solve it. In I2 also, I will divide it by t² and solve it. And it is same what we did previously. So this question you have to complete on your own. Let's pick up the last example of this topic. I have to integrate 1/sin⁴ theta plus cos⁴ theta. So I told you whenever you have a sine and cos with the powers, we divide it by the highest power of cos. So I'll divide numerator and denominator by clear. So it has become 1/cos⁴ will become secant ⁴ sine upon cos, it will be tan⁴ and 1. I can write this secant⁴ as secant² theta into secant square, and 1 secant² I am writing as 1 plus tan² theta. Alright, and you know that whenever we have a combination of tan and secant square, we always substitute tan theta. So it has become secant² theta d theta dt. Put the value, secant² theta d theta is dt. This is 1 plus t² upon t² plus 4 t⁴ plus 1. So I got the form. This is my form. Alright, what do we do in this form? We divide by t², so it will be clear. Then what do we do? If it has a plus, so we always substitute t minus 1 by t. By now you know it. So it has become dy 1 upon, how do we get the value? By squaring both sides. So t² plus 1 by t² is y² plus 2. Which form can be correlated with? 1 upon x² plus a². So what is the integration? So many times we have done now. 1 by a tan inverse x by a. Replace the value of y first of all. That is, little simplification here. I can take LCM. t² minus 1 upon √2t plus c. Put the value of t back. That is plus c. Is this clear, children? So this was all about this form. Whenever we have the form either x² plus 1 upon x⁴ plus 1, that means the standard form, x² plus 1 upon x⁴ plus kx² plus 1, or x² minus 1, the denominator remains same. So this is the procedure what we follow. We divide the numerator and denominator by x². We substitute either x minus 1 by x or x plus 1 by x, and then we proceed. So this was all about your indefinite integration. Alright. After this, we are going to start with definite integration. And again, children, I would like to say, indefinite integration, many forms are there. Different questions would be there. You have to practice it well. Then only you will be able to solve the question of integration in examination. Because in integration, lots of thinking process is involved and lots of practice is required. So with this, hope that you all would be practicing properly and you will be able to solve whatever the question come on your way. We will be putting off with this indefinite integration now.